Today we will learn about the chromosomal aberration. Chromosomal aberration or chromosomal anomaly. This is the karyotype. Now karyotype is what? The photographic representation of chromosome in the descending order of its length. This is a human karyotype. So this is the human chromosome, and it is diploid. Every chromosome has two chromatid, one from the father and one from the mother. So we have got 22 pair of chromosome. This is the first pair, second pair, third pair, fourth pair, one from the mother and one from the father. So these are the paired chromosome, 22 pair, and this is the last one is the sex chromosome. This is X and this is Y, so this is male, and if there are two X, then that will be female. So it is the photographic representation of the human chromosome in its descending order of its length. So chromosome 1 will be the more lengthier, the lengthiest, and the chromosome 22, it will be the shortest. These are the 22 pair, these are the autosomes, and only one pair of sex chromosome. Okay. Now, how it is arrested? It is arrested by the colchicine. By putting colchicine during the cell division, the chromosome is arrested in metaphase. And in the metaphase, there will be more condensation of the chromatid. So it will be highly visible. Okay. So they are arrested in metaphase, the Gemsa strain is used. So this is also known as Z banding technique, because we use Gemsa strain. If we use quinacrine strain, then this will known as the Q banding. Okay. Now, according to the position of the centromere is that position of a chromosome where during the metaphase it is attached with the opposite side chromatid, their corresponding chromatid, where from it is attached, then that part of the chromatid is known as centromere. It is attached in the middle. During the cell division, they are going apart, and here this is the area which is the last to depart. With the help of mitotic spindle, they are attached with the pole, and then they are getting apart. So this part is the last to apart. That is called the centromere. Here, chromosome number 1 and 3. 1, 3, 16. 1, 3, 16 and 19, 20. These are the metacentric chromosome, because the centromere is situated in the middle, and it look like letter B. If they are getting apart and only this area is attached and two limbs are they are departing, then it will look like letter B. So 1, 3, 16, 19 and 20. In human, these are the metacentric chromosome. Now, what is submetacentric? Near about the middle. The most of the human chromosome are submetacentric. And if we have to give example, then 4 and 12. Okay. Now, what are the acrocentric? Near about the end, but not at the end. These are acrocentric. These are the 13, 15. Okay, 13, 15, 21 and 22. These are the acrocentric chromosome. In the acrocentric chromosome, Robertsonian translocation occur. I will discuss later on what is Robertsonian translocation. These are the acrocentric chromosome, in which this is the short arm at one side. This is short arm and the long arm. Short arm is very short and long arm is very long in acrocentric chromosome. Short arm is also known as P, and that is from petit, P-E-T-I-T, and Q arm is from the word Q, Q में रहो, Q-U-E, क्योंकि P के बाद Q में रहता है Q, इसलिए that is Q arm and this is P arm. Okay, now this is one code word in the genetics, that what it by decoding what we will get, that it is the with reference that it is the diploid cell. What is, if they are not in pair, only 22, not 22 pair, 22 chromosome, then that will be the haploid cell. Like germ cell is a haploid cell, and the diploid cell is, every somatic cell is a diploid cell. Okay, so this shows that it is diploid cell, 22 pair and plus XY chromosome, so total 23 pair, that is 46. Okay, and it shows the gender, that it is male, XY, and T for translocation between the 2 and 5, that is the chromosome number 2 and chromosome number 5. The translocation occur in between these two. P13, Q33, P13 for the chromosome 2 and Q33 for the chromosome number 5. P13 for chromosome number 2. This is chromosome number 2. P means short arm. This is the submetacentric type of chromosome, most of the chromosome. So here, suppose this is the centromere. So this is the short arm. In the short arm, 1-3. 1-3 is 1 shows the region and 3 is band. Now what is region and what is band? Suppose this is the chromosome, this is the centromere. In yellow color, these are the region, and within the region there are banding pattern. Okay, suppose this is the region 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the region, this shows the region 1 banding 3. This is region 1, 2, 3, 4, 5, 6. The yellow spot shows the region, and the banding within the region, band 3. Within the region, band 3, that is first band, second band, and third band. So here, this gene which is located here in chromosome number 2, and the P, that is short arm, region 1, band 3, translocated with chromosome number 5, long arm, that is Q arm, region 3, band 3, region 3 and band 3. Always region and band are counted from the centromere outward, like this 1, 2, 3, 4, 5, not away. 1, 2, 3 not like counted, it is from the centromere. If I have not region and band, I have not made region and band here, so if it is present here, so it will be counted from the centromere outward. Okay, so these are the decoding technique. Like this, here the 47 chromosome, that is the extra chromosome is there. Here is the numerical anomaly, and there are 3 X chromosome. 1 X chromosome is added, so there is a problem in 6 chromosome. And here is also deletion, Where deletion occur? In the 6th chromosome, chromosome number 6, in the Q, that is the long arm. It is also submetacentric. If centromere is here, the long arm, and 34.2, that is the region 3, band 4 and subband 2. In the long arm, region 3 towards the centromere, band 3 and subband 2. If this is band, then from subband 1, 2, 3, 4, 5, 6, 7, subband. So 0.2 means subband 2. Okay, this is the decoding pattern. Now, how the chromosome, which type of chromosome aberration occur in it can be the numerical problem or the structural problem. Numerical problem, if suppose one chromosome is added or one chromosome is the one whole chromosome is deleted. So that is a numerical problem. There is no changes in the structure. No changes in the structure of the chromosome. Only the numbering differ. That type of anomaly is called the numerical chromosomal aberration. Like if one chromosome is attached when added in 13. In the 13th chromosome, one chromosome is added, extra chromosome, then it will be regarded as trisomy 13, that is the Patau syndrome. If one chromosome, whole chromosome is added in chromosome 18, this is the Edward syndrome. If one chromosome is added in 21, so trisomy 21, this is the Down syndrome. Just to remember, 13 is the age of puberty, so Patau syndrome. 18 is the age for the election. You can vote. So E for Edward and E for election. So trisomy 18 is Edward syndrome. D for drinking. In many European countries, the drinking is legalized from the age 21 onwards. So 21, D for drinking, D for Down syndrome. Trisomy 21 is also known as Down syndrome. Okay, so these are the suppose if one chromosome is departed, like in the Turner syndrome, XO is there. That is the insects. I'm talking about the autosome, but when the Y chromosome is not here, only one X chromosome, then it is regarded as XO. Suppose this is a female child, 2X chromosome is there, and one X is not. So genetically female. Turner syndrome, genetically female with one X chromosome, XO. That is called Turner syndrome. Klinefelter is XXY. Again, here is the problem with the sex chromosome, and the person will be XXY. That is the male with extra X chromosome. If triple X is there, again, here is the problem with the sex chromosome and the female with extra X chromosome, super female, that is known as. And if there is a structural problem, suppose this is the chromosome, suppose this is the chromosome. If one part of the chromosome from anywhere it is coming and added, so this is called addition. If this is the chromosome and one part of it is departing, only this one is left over here, so this is called deletion. Example of deletion is the Cry-Du-Chat syndrome. In chromosome number 5, the partial deletion of P arm occur, 5P, that is the short arm of 5th chromosome, in which partial deletion occur, and that will result into the Cry-Du-Chat syndrome, in which the baby cries like the cat sound. That is called cry-do-chat syndrome. So example of deletion is cry-do-chat syndrome. And the addition, like that, the numerical problem, as well as the one chromosome is added. And addition, I will discuss the example later on. Okay, so this is deletion if some part of it is deleted. Now what is inversion? If it is separated and again it will get somersault and then again added, this is called inversion, because it is inverted, palat gaya hai, inverted. This is called inversion. So we have discussed addition, deletion, inversion, translocation. If suppose this is one chromosome, this is another chromosome, one chromosome, this is another chromosome, one part of it come here and with the exchange of few part of chromosome going there. So this is translocation, the exchange of genetic material, exchange of chromosomal arm. Okay, the example, it is of two types, the simple translocation and the simple and reciprocal translocation, and the Robertsonian translocation. In simple translocation, there is the example is bucket lymphoma and the chronic myeloid leukemia. In chronic myeloid CML, chronic myeloid leukemia, there is the chromosomal translocation in between the chromosome number 9. This is chromosome number 9 and chromosome number 22, this one. In these two, there is exchange of genetic material occur, 9 and 22. Okay, where अबुल बकर 9 से 22 साल का होते ही मर गया. अबुल बकर, ABL जीन ऑफ क्रोमोसोम नंबर 9, BCR बकर ऑफ क्रोमोसोम नंबर 22. इन दोनों में एक्सचेंज हुआ तो CML, ब्लड कैंसर हो गया, उसके बाद मर गया. अबुल बकर 9 से 22 साल का होते ही ब्लड कैंसर से मर गया, just a mnemonic. And one is the Burkitt lymphoma. इसमें क्या होता है कि C Mike gene and the one is C Mike gene and BCL2. There are two genes are translocated from their places. Okay, C Mike, and in between the chromosome 14 and chromosome 8, chromosome 14 and chromosome number 8, in these two, the translocation occur in between the gene C Mike and here the gene BCL2. Translocation occur and it will result into the translocation occur between the IG gene and C Mike, IG and C Mike, and this translocation will result into the BCL2 proliferation. There is one, due to the translocation of these genes, there is overproliferation of BCL2 gene that will result into the Burkitt lymphoma. And Robertsonian translocation occur only in case of acrocentric chromosome. These are the acrocentric, that 13, 15, 21 and 22, in which the translocation occur if both short arm will be translocated one side and both long arm at one side. So short arm, there will be few, in that case, if short arm is lost, that portion of the chromosome will remain viable, which will contain the centromere. If suppose this part is removed, the short arm is removed without centromere, that will be degenerated. So what will be left? The long arm of the in between acrocentric chromosome occurs, suppose 13, between the 13 and 15. So only the long arm of both sides will occur. So there will be little loss, because the short arm here, the acrocentric, it contain only the protein which forms the ribosomal RNA. So there is not that much of loss. And it is also worth mentioning that the Y chromosome, sex chromosome, that is Y chromosome, is also acrocentric. Sex determining region lies in the Y chromosome. Okay. So in Robertsonian translocation, the small arm will be deleted and only long arm will be there, and that will remain, and there will be not such big problem in the baby in case of Robertsonian translocation. And it often occur along with the these are the structural problem along with the numerical problem, like trisomy 21 with the Robertsonian translocation. That is the numerical problem plus a structural problem. So that will be more dangerous. But due to the Robertsonian translocation, it becomes familial. Normally the Down syndrome is not familial, but due to the Robertsonian translocation it becomes familial. Okay. So this is the few example of the chromosomal aberration. Thank you. One thing more, what is aneuploidy and what is polyploidy? In the numerical problem, if one chromosome is added, chromosome 1 or 3, that is n plus 1, n minus 1, n plus 2, n minus 2, like this. N is what? N is 23 chromosome. N means 23 chromosome is also known as N. 2N is 46 chromosome. So N plus 1, that is 24 chromosome. This type of anomaly, this type of numerical problem in which only one chromosome is added or one chromosome is deleted, or 1 or 2 or 3, but they are not multiple of N. Like not multiple of N is what? 23, 46, which comes in the table of 23. If it is the multiple of N, then it is known as polyploidy, like 2N, 3N, 4N. These are the polyploidy. N is what? N is the haploid cell. 2N is diploid cell. 3N, 4N, these are found in the cancerous cell. Okay, and these are euploidy or polyploidy. And what is aneuploidy? When they are not, there are numerical problem, but they are not multiple of N. This type of numerical problem is known as aneuploidy, like N plus 1, N minus 1, N plus 2, N minus 2, 2N plus 1, like all these. These are the aneuploidy. Thank you.